All right, electricity class. This is a problem I wanted you to do as practice. Um, it looks a little bit different than the other ones, but I was just wanting to see if you could do it based on the things that I've taught you. I hope so. So here's what you needed to do. If you hadn't noticed, I mean, obviously they gave you total voltage. All right. If you look at our rules under a parallel circuit, the voltage drop across any branch of a parallel circuit is the same as the applied voltage. All right, so you should know, because there's only one resistor at each one of these places, that this branch is going to get 120 volts, and this branch is going to get 120 volts. Okay, so you get 120 volts at both of those resistors. Now, because I got two resistors here, I can figure any of these out. And if I look at my next rule, the total current flow is equal to the sum of the currents through all of the circuit branches. Again, we know we only have one resistor here, so if I figure out my amperage here and my amperage here, it says the total is equal to the sum. So I will add those up and I will get this. And I'll have two variables there, and all I have to do is use my Ohm's law. So that's what I'm going to do. If I know power and I know volts, power divided by volts gives me amps. All right, so power. Okay, I'm going to clear that. Power for resistor 1 is 72. So power divided by 120. So my amperage for resistor 1 is 0.6 amps. 29 divided by 120. And again, I'm going to round here, so these all just go up. So 0.242 amps. So 0.242 plus 0.6, and we get 0.842 amps for our total. Okay, now resistance up here. Let's go ahead and figure those out first. Down here, the easiest one is to divide volts by amps. 120 divided by 120 divided by 0.242, and we get 495.868 ohms. Okay, do the other one. 120 divided by 0.6, and we get 200. All right, we can do the same thing over here, right? 120 divided by our total, 0.842, and we get 142.518. Ohms. Now, let's check this. Our last rule says the total resistance, whoops, I better get this in the screen. The total resistance of the parallel circuit is always less than the resistance of the lowest value resistor or branch in the circuit. So that means which one of these is lower? 200 is the lowest. Our total is lower than our 200. So that follows the third rule. And then finally, wattage is always going to be volts times amps. My dog started barking. 120 times 0.842. We get 101.04. 101.04. Now, the reason typically if you add this and this together, you should come up with this, right? Well, 70 plus 30 is 100. So 72 plus 29 is 101. Where do we come up with that 0.04? Well, it comes from us rounding these numbers. When you round, because you saw some of them were much longer than just 3 places after the decimal. When you round down, it gives you a little bit of error. So when you start doing that, numbers may not match up perfectly, but that's pretty darn close. And we're going to say that's good. And that's how you do it. So it was a little different. It made you use the logic a little differently, but it is all the same stuff. It's not all that hard. The hardest part is round to 3 places after the decimal, label this stuff. Okay, I'm not going to give you for the test anything super difficult, but it might be something like this. At least you have to show me that you know the basics on how to go about this. Okay? All right. Thanks, guys.